Okay, diagram दिसते सगळ्यांना?
हो दिसते.
Next topic is electromagnetic flow meter. Previously we have studied about variable head type and variable area type of flow meter. Now next is the electromagnetic flow meter. This type of flow meters are generally used when the type of fluid is of conductive type, means through which a current can be passed or current can be flow. In such a case, we have to use electromagnetic flow meter to measure the amount of flow passed through the pipe. That means to measure the overall flow rate. For that purpose, it consists of simply one permanent magnet, a C-shaped magnet, over which a coil is wounded. To this coil, we apply one external power supply, that is the external voltage source. Next, into the pipe, into the C-shaped core, we fixed one pipe through which we are going to pass a fluid, and to this pipe two electrodes are fixed. These electrodes are in such a way that they are perpendicular to the pipe axis, means it is perpendicular to pipe axis, also the field generated by the magnet. So field is in this way, it is in vertical manner, and you are going to implement the axis in electrodes in horizontal manner. So both will be perpendicular. Also, when the fluid is passed through the pipe, it is also perpendicular to the direction of magnetic field. So here we have to consider the basic working principle of electromagnetic flow meter based on Faraday's law of electromagnetic induction. So where it states that when a current carrying conductor is placed in a magnetic field, then an EMF is induced across that conductor. So now current carrying conductor or the moving coil. So you can say here the current carrying conductor is nothing but the pipe through which we are going to pass a conductive fluid. Okay. So ज्याच्याकडनं करंट पास होणार आहे, म्हणजे जो लिक्विड असा आहे की जो काय कंडक्टिव्ह आहे, करंट पास होऊ शकतो असं फ्लुइड आपण यूज केलं. So that fluid will pass through this pipe. After that, when the magnetic field will produced by the permanent magnet due to this coil wounded over this permanent magnet. So what happens due to Faraday's law of electromagnetic induction? It states that the EMF is induced across this conductor, and this EMF is given by E is equals to BLV, where B is the magnetic flux density and L is the length of conductor. Now length of conductor is nothing but the pipe. The pipe which is fixed between the C-shaped permanent magnet. So that much length we have considered here. So length of conductor, then V is the velocity of fluid passing through this pipe. So as you know, the pipe length of conductor, that means length of pipe is fixed. The flux density or the magnetic field generated by this C-shaped magnet is constant. So your EMF induced across this conductor will be directly proportional to velocity of fluid passing through this pipe. Okay, so which is the major condition that whatever the EMF induced across this conductor, it will be directly proportional to velocity of the fluid. It is very simple. So electromagnetic flow meter generally used where we have to measure the flow rate of conductive type of liquids or the fluids like acids or alkalines. So for that purpose, we have to use electromagnetic flow meter. So I repeat it again. Here it consists of a C-shaped permanent magnet over which we wound the coil. To the coil we apply external power supply. In between C-shaped permanent magnet, we fixed one pipe through which we are going to pass a conductive fluid. To this pipe we insert one electrodes opposite to it, two electrodes opposite to each other, which are perpendicular to both magnetic field generated by this permanent magnet and the axis of the pipe. Okay, then this pipe is actually made up of non-conductive material or non-magnetic alloys. Okay, so it may be made up of glass or it may be made up of any non-conductive material. Okay, so to avoid any short circuit, we have to use the material of pipe should be non-conductive only, because we are going to pass a conductive fluid through which, and we inserted two electrodes. through which we are going to through across which we get the electromotive force. Okay, and this electromotive force is given by, means electromotive force means EMF, which is given by E is equals to BLV. Okay, so it is very simple. As the flow is passed through the pipe and EMF is induced across these electrodes, and this EMF is can be measured by the formula is equals to BLV, where B is the flux density which is constant, L is the length of pipe which is constant, and V is the velocity of fluid, and this velocity of fluid is changing and it is directly proportional to EMF. ठीक आहे, क्लिअर? कोणाला काही डाऊट आहे त्याच्यामध्ये?
No.
ओके, व्हेरी गुड. सो व्हेरी सिम्पल. आता याचे ॲडव्हान्टेजेस काय असणार आहे? इट कॅन बी यूज फॉर एनी टाईप ऑफ कंडक्टिव्ह फॉर लॉंग डिस्टन्स फ्लो मेजरमेंट, म्हणजे जिथे तुमचं पाईप साईज पण इन्क्रीज होते, लार्ज पाईप साईज असेल तिथे पण तुम्हाला यूज होतं. त्यानंतर ॲसिड अल्कलाईन टाईपच्या फ्लुइड्स जे असतात त्या मेजरमेंटसाठी तुम्ही यूज करू शकतात. आणि इथे काय, हा इनडायरेक्ट मेजरमेंट मेथड आहे, मीन्स देर इज नो डायरेक्ट कॉन्टॅक्ट ऑफ एनी ह्युमन बिंग. हा इनडायरेक्ट मेथड आहे विच इज व्हेरी ॲडव्हान्टेजियस ॲज कम्पेअर टू प्रिव्हियस वन. ठीक आहे. प्लस त्याच्यामध्ये अजून डिसएडव्हान्टेजेस काय येणार आहे की इट इज ओनली ॲप्लिकेबल टू कंडक्टिव्ह टाईप ऑफ फ्लुइड्स. हा मेन ड्रॉबॅक आहे त्याला. इतर कुठलेही फ्लुइड चालणार नाही. सिम्पल तुमचा जो काही ज्याच्यामध्ये कंडक्टिव्हिटी नाही आहे असे लिक्विड्स पास करू शकणार नाही, बिकॉज वी नीड टू induce the EMF. For that purpose, we need some conductor which carries the current. So conductive fluid is compulsory for this type of electromagnetic flow meter. ठीक आहे. सो ह्या व्हिडिओ नंतर याच्यानंतर मी तुम्हाला एक छोटासा व्हिडिओ क्लिप दाखवते, ती पण तुम्ही बघून घ्या.